Hello everyone. Welcome to another Net and AI Community Startup Edition. We have a very long name. I need to figure out, talk with the marketing people and change the name. I want a shorter one. But hey, I'm super happy today because we are going to talk about evaluation. So I know I need to introduce myself. So Bruno here from the Cloud Advocate team. I'm super happy to be here with Peter and Shyam today. And hey, do you want to introduce yourself, please? Super quick or whatever you want, Peter, please.
Sure. So I'm Peter Waldschmidt. Work for Microsoft on the a team that's building these Microsoft.Extensions AI. Work in the developer division, create a lot of testing and tools for developers.
Oh, super nice. Shyam?
Hey everyone, I'm Shyam. I also work on the same team as Peter, working on Microsoft Extensions AI Evaluations library at the moment, and a bunch of other AI stuff.
Oh, super cool. And hey, by the way, thanks everyone. I saw a couple of people from Brazil, San Diego. We have also been here from India, Jorge, also a lot of people. So hey, thanks to everyone. And let's go super quickly today to start. I see there is a lot of people. Remember the deal. I'm taking a look at the comments. We have a 10-20 second delay between the comments. Let's try to, if someone has a question, I will pin the question to the queue and we figure out how to answer. But because this is a new topic and we have a lot of stuff, and you probably heard a lot of times Microsoft Extensions AI in the last streams. So if you are okay, Peter, I can add your screens here and we can start. Let's go. Perfect.
All right.
There it is. It's all yours.
All right. So we're here to show off this new library that we just open sourced. It's been available for a few months, but we finally open sourced it, and so I'll tell you a little bit more about it. So basically, it's actually a collection of libraries, all under that same namespace, Microsoft Extensions AI.Evaluation. And there's three primary things we wanted to share about it. First of all, they are modular open source libraries. It's a set of libraries. They're built to work together, and they're targeted at helping you evaluate LLM responses. So lots of people are building different kinds of copilots or different kinds of chatbots, et cetera, that work with AI. And one of the big challenges in building an application like that is to be able to understand when your program is getting better or when it's getting worse, what types of things it's good at, what types of things it's not good at, and as you build it and maintain it over time, making sure that it's going in the right direction. So it's sort of like unit tests. You can think of it in sort of a similar way, although it's not exactly unit tests. And so because of that, we built it in a model that is very friendly with unit tests. So you don't have to use unit tests to wrap up these evaluators, but we built them in such a way where it fits naturally into unit tests so that you can easily run them in Visual Studio, run them in VS Code one at a time while you're developing. And then you can just as easily plug them into a CI pipeline and run them on every PR or every time you make a major change. So it is designed around evaluators that use LLMs, although they don't require LLMs. So it works very well with evaluators that, and I think Shyam will show this later too, but it's designed mostly for LLM-based evaluators, but there are plenty of evaluators that just use, whether it's math or whether it's special services or special finely tuned models that can provide evaluation in a slightly different way with a different model. So we support that as well. So it is a library of evaluators, right? So not only is it built for testing, but it includes a model or a set of its own evaluators. There's a few of them here listed just for reference: relevance, truth, completeness, coherence, groundedness, fluency. There are a set of evaluators also that are built into the Python SDK, the Azure Python SDK, and that are available in AI Foundry in Azure, if you're familiar with that. And these evaluators are designed to be, but they're basically the same evaluators, just wrapped in C# code instead of Python code. And we're working with that other team, the team that manages the Python team, to share knowledge and experience here and to keep those kind of advancing together. But we didn't want C# developers to have to go and write Python in order to get their apps tested. So this allows you to write it in C# and natively integrate it. We do have coming soon more types of evaluators. Safety is coming very soon, hopefully within the next month or so. It is things like content safety, intellectual property, protected material, protecting against kinds of attacks like injection attacks, both internal injection attacks and external injection attacks. And there'll be more of those as well as we go on. Those actually require a service, an Azure service to run, because they require additional models and additional support that isn't available in just connecting directly to an LLM. So those will be packaged in this library, and then you will also have to create an instance of a service on Azure that it will talk to do those evaluations. Lastly, there's a set of evaluators that are basically math-based that don't use an LLM at all. They basically just compare two strings of text using some sort of metric. And that's what those ones there at the bottom, F1, blue score, rouge, there's a whole bunch of these. A lot of them are used in language translation sort of metrics and things like that. And so we do plan to offer those as well. And then the third part of this, which actually is really one of the big benefits of this package, is the infrastructure that comes along with it. So in addition to providing these evaluators, we also have some other support pieces like request caching. So you'll probably know if you're running large groups, hundreds or thousands of these evaluation tests, they're going to be running against your LLM, and they're going to be racking up a lot of tokens and creating a lot of cost. They also can take a lot of time to run. So what we do is, if you're running the same or very similar requests over and over again, we can cache those values as long as they haven't changed for a certain period of time, and then replay them. So that way your tests run much more quickly, like potentially the difference between a few minutes versus a few hours if you've got a lot of evaluations to run. And they also cost you a lot less money. So that's always good. We also have some storage providers that allow you to take the results from these evaluators and to have a standard way of storing them and keeping track of them and managing all that data. We have implementations for disk and for Azure storage. So one of them just stores them in a folder. It's up to you what to do with that folder. The other one stores it in a very similar format in Azure storage. For very, very large sets of evaluators, the disk storage can become kind of unwieldy, especially if you're using it. Like, some people will write their reports to disk and then check those into a Git repository, and so that way you can sort of download them back down again and use that cache again. But if they become very, very large, they become really too unwieldy for a Git repo. It's taking a very long time to run. So that's why we introduced the Azure storage one. We do have an example that's also supports SQLite, and all of this stuff is extensible by implementing some interfaces. So it's very easy for you to write your own if you've got some kind of special need that you want. And of course, we will probably continue to add more capabilities and more providers over time as well. We do also have a plugin for Azure DevOps that allows you to run a pipeline in Azure DevOps, and then there'll be a tab if you run these evaluations and publish your test results into the pipeline. Then it will add a tab to your view there, and that tab will show the report. And I skipped over it a minute ago, but we do have a tool, a console tool, that generates reports, and it basically can generate the report in the form of a bunch of JSON data, which is just basically the data collected from the evaluation run and stored for you, that you can parse yourself and use yourself in whatever way you'd like. And then we also have an HTML report that's built in, which makes it really nice. It's dynamic. You can scan through it, and it even has support for things like filtering and aggregation, and looking at trend history is coming soon. So yeah, that makes it very nice to use. We do also have plans to add support for GitHub Actions.
Yes. Before we move forward, and by the way, I love everything. We have Ravi here in the chat saying that, thank you, I don't want to write evaluators in just Python. So yes, you are literally the right audience for today. And I share the link of the blog post that we share on the .NET blog post team. I think it was 1 month ago, a couple of weeks ago, I can't remember. where you can also take a look at the links, and this is the ADO sample for doing the report there. And by the way, it makes a lot of sense. When I start to see this fluency, coherence, and more metrics, I came from a different background with machine learning. I'm so used to the F1, to the accuracy and more. This was new, and say, okay, this is something else. It's not something else. It's different. I also have literally what you mentioned in the path. I learned about this first in Azure, in the portal, in the Azure AI Studio back on those days. Today, Foundry. I learned about this on PromFlow, and hey, I'm really happy that we have tools to work at super high level, as you mentioned, with crazy set of data using Azure Restorer, or maybe something local, more, I will say small. It's not small because SQL Little is great, but you can even do this in a different scale with this. So, hey, I really appreciate to have these libraries for the .NET developers. So the people are sharing that kind of couple of questions about this, but in the meantime, I want to say that hey, if you are doing AI, if you are planning to use large language model, this is something that you need to, at least you know that it's in your toolbox. Later, if you can choose if you want to use it or not. So sorry, Peter, I just want to thank Ravi for sharing the question, his feedback, and also to add my 2 cents there.
Yeah, absolutely.
And I love the flow here. Oh, this is super cool.
Thanks. Yeah, we've actually, a lot of this stuff is built from experience. So, we work with a lot of different teams all across Microsoft that are building different AI products. And so rather than having them each build their own solution for this, we said, well, let's just pull together a common solution and share it out. And so that's the point of this, is being able to help people move more quickly. So I wanted to show a diagram here because I think this might make it easier for you to visualize what's happening, because it gets kind of complicated. And when Shyam goes through the code, it may not be as easy to visualize the complete, scenario from code alone. So I'm going to go just real high level here. Basically, your app and your tests, your evaluation code is in this box right here. So let's say you have a chatbot, and this is your AI chatbot here, and you want to see how well it is doing at answering the questions. Basically, you're in your tests, in your code that's sort of orchestrating these tests, it will take a sample question from that you're trying to analyze. It will run it through your chatbot. So your chatbot sends it to an LLM, presumably, and then it gets a response back. And then we take that, what you sent as well as the response, and we pass it off to the evaluation library. And we put together those evaluators, and those evaluators will take everything that you sent, what you received, along with some evaluation prompts, and send that again to the LLM. These could be 2 different LLMs, by the way, but we'll send it to an LLM, get back the response, and then evaluate those responses and determine, score them in various ways that you'll see. And then that data is then sent to the report store, which again was what we talked about being on disk or being in Azure. And then it can just sit there if you'd like. But then we do have this .NET AI.Eval, which is a console program that's also part of this evaluation set of libraries. And it knows how to read the report store. And so it can read out of that, and then it can generate the HTML and JSON report. So this whole entire thing could be done in a pipeline that runs constantly, that's constantly measuring and reporting how well your application is doing at responding to these requests based on these evaluators that you set up. So a couple of other notes. I noticed a note at the bottom. Some evaluators don't use an LLM. So again, there's no requirement for them to use an LLM, but a lot of them do. And then the response cache in the middle. So potentially, if it's cached, it could, instead of going all the way to the LLM and coming back, it goes to the cache and just sort of short circuits through there. And the response cache can also be used in your own app. So not only can it be used with the evaluator, but if you use our supported, Microsoft.Extensions.AI libraries, and you plug it in to your app, then your app can also benefit from that same caching in the testing. Okay. And then
that's super cool. And by the way, sorry, thanks, Shyam. I just shared the link to the repo, to the main entry point where you can see the samples and more. It's part of the resources, but it's in the chat. And I think I know the answer, but let me make a super question for the 2 of you here. Robson in Twitch is asking that, are these tools related to ML.NET? I said no, but I may be missing something here. Are they related?
So they're part of the same family, but they are not directly related. There's no like dependencies between them. You could use them together potentially, but it's built on Microsoft Extensions AI. So the whole stack of Microsoft Extensions AI is basically the only thing that it requires.
There is, we do have a dependency on the ML tokenizers library, which contains all the different LLM tokenizers, but other than that, there shouldn't be any.
Oh, yes. And we don't need to start to talk about tokens. Last time that we started to talk about tokens, we spent literally 45 minutes talking about tokens and more. So let's not go back there. I will share the link to the previous token discussion just in case. But no, thanks. Sorry, it was a question I was thinking it's not related. But yes, it's under the big family right now is Microsoft Extension AI. Everything is going there. Sorry, Peter, back to you.
Yeah, so just to wrap up here, I just wanted to outline what each of the current libraries we have today that's part of the family, and they're all released together and working together. The core one is called Microsoft Extensions AI.Evaluation. It's got the core abstractions, the core pieces that you need to make this work. We have a set of evaluators, the quality evaluators, which are in evaluation.quality. We have safety evaluators, which are the ones that require the external service. Those ones are coming soon. They're not released yet, but they'll be in a library called evaluation.safety. We have evaluation.reporting, which includes the caching infrastructure as well as the infrastructure for saving your evaluation results. We have the reporting.azure, which basically is the same thing as reporting. It just adds the Azure pieces to it. And so it's a separate library so that you don't have to pull Azure dependencies into your app if you're not using that part. And then evaluation.console, there should be a dot there, but which is the command line tool that generates reports and helps you manage your data. It is designed to be layered and very modular so that you could use, like, for example, you could put this in a runtime app in production that just maybe if your chat app is responding to requests, but then in the background you have a little service that's taking those requests and evaluating them in the background just to see how your tool is doing live or something like that. You can completely do that with those. There's no reason why it has to be in a test environment only. And again, the caching is optional, and the reporting is optional. So you don't necessarily, you could just be, grabbing the evaluation results out of the responses and then just, throwing everything else away. You don't, it's all optional as far as how much of the pieces you want to put together. So then finally, just some links, and we can share these out as well, but just some resources for who to contact if you want more information. And with that, I'll turn it over to Shyam.
Awesome. Thanks for the cool introduction, Peter, and Bruno for hosting us. I will, could you share my screen, Bruno?
Perfect, yes, there it is.
Awesome. So just wanted to point out that the whole evaluation library is open source. All the samples that I'm going to demo today, they are available at this link, which Bruno has also shared. And the libraries themselves are shipped from the .NET extensions repo, which is the same repo where Microsoft Extensions AI ships from. So that's the place to go if you want to report feedback and look at what our roadmap looks like and so on. And with that, over the next maybe like 20-25 minutes, I want to give you an overview of the code and how everything is wired up, and then also show you what the report looks like, and then we can go from there. We'll save some time, hopefully, at the end for question answers. So this is the, as Peter was mentioning, like there is multiple libraries, but they're all layered on top of each other. The primary core one that we have is Microsoft Extensions AI Evaluation, and it defines all the core abstractions that are required for doing evaluation, look like the abstractions for the results and the scores, the interfaces you need to implement to write your own evaluators and so on. On top of that, we have evaluation.quality, which contains some inbuilt evaluators that we are shipping currently, and I'll show you some of those in the code. And then the reporting layer is on top of that. If you want to use this in a unit testing context and then generate a report with all the evaluation scores. So the main interface that we have in the evaluation layer is called evaluator. And this is the interface that all the evaluators in the library implement, including all the ones in this quality package. So there is just one method on evaluate async, evaluator, which is called evaluate async. And the inputs are, so this is the chat history or the conversation for the conversation that you're trying to grade, right? So this is all the messages that were sent to the LLM, and then the LLM produces this response. So the evaluator is passed the whole chat history and the model response. And then we have this chat configuration class. So if I go to that, what it contains is mainly two things. Like one is a chat client, and this is coming from the Microsoft.Extensions.AI library that we're built on top of. So this is the iChat client defines how to talk to the LLM, right? So when you use the Microsoft.Extensions.AI evaluation library, you essentially provide the library with a chat client that knows how to talk to your specific LLM. So for example, it could be a chat client that can talk to OpenAI, like the model of your choice, like GPT-4o, GPT 3.5, or it could be like talking to Olama on your machine. All of those kind of different LLM providers are supported. So you provide the iChat client and an evaluation token counter. And what this is doing is like, if your messages or your history is too large, and if you have specified like a input token limit for your model, then we can internally kind of trim the history so that it fits within that token budget. So depending on the model that you choose, a different tokenizer needs to be used, and therefore the input, like along with the chat client, you also provide this token counter. So the next parameter in the evaluate async is additional context. So this is required for some of the evaluators, such as the groundedness evaluator or the equivalence evaluator, which needs some kind of context to say, is the conversation that we are seeing with the messages and the model response, is that good or is that bad? So some kind of, for example, in the equivalence case, the evaluator is being asked to evaluate if the response that was produced is similar to another one, like a golden response that I'm giving you. And that golden response will kind of be passed through this additional context. And so this is like a collection of evaluation contexts, and each evaluator can decide, I need 3 different types of contexts, and like you can pass all of those contexts when you call evaluate async, and we'll see some examples of this later. So that's the main inputs for the evaluate async. The output is an evaluation result, and an evaluation result is just a collection of evaluation metrics. It doesn't have anything else. And if you go into evaluation metric, we currently support 3 types of metrics. So the first is a numeric metric, and numeric metric is like a score, right, between 0 and 5. So for example, fluency, how fluent is the LLM, your chatbot, in responding, right? That is measured as a score between 0 and 5. So that would be represented using a numeric metric. Then we have the Boolean metric, and Boolean metric is for yes, no, pass, fail kind of analysis. So we'll see some examples of that later as well. And then string metric is for when you want to represent like one value out of many fixed set of values, right? So it's more like an enum. So if your evaluation result is like, we'll also see an example of that, like where you want to represent like some string as your metric name or metric value rather. So having said that, I'll quickly show you a sneak peek of the report. I'll show it again at the end, but then I just wanted to make you kind of aware of the concepts, right? So each card in this report is kind of one of those metrics, right? And so relevance, truth, completeness, these are inbuilt metrics that we ship as part of the quality package. And these like the words metric and the measurement system metric, these are from the sample. So these are from an evaluator that I implemented myself. And so each of these is an evaluation metric. So in this case, words, relevance, truth, and completeness are all numeric metrics. And measurement system one is a string metric. So as I said, I want to know what the measurement system was. And in this case, it has graded that the measurement system present in the LLM's response is the imperial measurement system. And I'll go over like exactly what that means in the sample. So with that, I think we can jump to see an example of how these evaluators are used. So as I mentioned, like the samples that we have, like they're split into two projects as well. So there is the evaluation project and the reporting project. And this is mainly demonstrating the layering that we have. So as Peter mentioned, like it is possible to use the evaluation libraries standalone without any reporting. So all the examples in this evaluation project are not going to use reporting. They're just going to show you different concepts around like how to use the evaluator and like the core evaluation abstractions. And then reporting kind of builds on top of that and says, okay, now that you know how to do evaluation, like how would you report those results? How would you hook in like the request caching and so on? So I'll start with the most basic example that we have inside the evaluation samples, and that is where I just want to invoke one evaluator, right? And so this is how the code for that would look like. So I create an instance of the evaluator that I want. So in this case, I'm creating an instance of coherence evaluator, which ships as part of the Microsoft.Extensions.AI.Evaluation.quality package. And then I say, coherence evaluator, please evaluate this conversation, right? So in this case, I have a couple of static fields where I'm storing the conversation. I don't want to repeat the LLM calls for those conversations in every test. So I just store them in a field and then use them in multiple tests. So the question here is something like, what is the distance between, and all these samples are using astronomy questions. So they are, what is the distance between Earth and a particular kind of planet or the moon or something? And then this is just the evaluator is evaluating the LLM's response for that. So as you can see, I've said coherence evaluator evaluate, I get back a result. And then there's a bunch of things that I can do with the results, right? So now that I have the results, I want to know how good the result is. So from the result, I know that because I called the coherence evaluator, there is going to be a metric with name coherence. And this is a constant that is available on the evaluator itself, which advertises the name of that evaluator. So I get that numeric metric. And then the first thing I do is like, I want to check whether it's failed. I want to check what the rating for the result is, right? So the value of the return metric, because it's a numeric, the value is going to be like some number, right? 0 to 5. And I can check the value and say that it should be greater than or equal to 3. But the library has this concept of an interpretation. So when the evaluator returns a metric, that metric comes with an interpretation of how good or bad that metric is. So the evaluator will say, should this score be considered a failed? Should the rating of that score considered be good, bad, exceptional, unacceptable, and so on? And while the evaluator can provide these interpretations, you can also override them. So you can say, for my set of tests, I want the coherence score to always be greater than 4. So I don't want to use what the evaluator has given me. And the library also supports doing that. And we have some examples of that, which I won't be going into.
Sorry, Shyam. Hey, I love this because it really makes things easy. I'm going to just repeat a little to see if I get this right. So we are going to have a value here when doing evaluation. It's going to be a number, but then we have this attached interpretation that is going to say, hey, this is fail, this is not fail. But at the end, we have the number 3. But we can work with that. If we want to be good, only 4.8 and bigger, we can override this and go there. Hey, I love this. And also, because we have here literally the right place. I think it was Ravi who was asking that if support local LLMs. So in the repo, was browsing the repo. I like to do this live, so I learn at the same time of the audience. If you take a look at the test setup in the evaluation project, they have a set of implementations so you can start and create your large language model to do the vals using OpenAI, Azure OpenAI, or even Olama. So yes, if you want to use a local large language model or SLM, another day discussion, you have the chance here to see there it is. You have the Olama configuration. So I'm guessing that, hey, if you want to run this locally, you want to test a model local, but then use a GPT-4 or Mini to do the vals. I love that we have, again, in my head, I need to go deeper. We have the chance to do A and B and C and work there. So I would say, Ravi, when he's asking here, supporting local LMs, I say yes, because Microsoft Extension AI, it's an abstraction and supports a lot of things. So I'm guessing that if we want to do this, I am correct. Like if we want to work with Olama and a couple of local models, it's fine, yes?
So I would say from the API standpoint, everything is supported, right? Like you can use any kind of model. But because you're using an evaluator, that model, how it performs against the evaluation prompt, it depends on the model size and the model quality, right? So the evaluators that we ship in the box, like in this Microsoft.Extensions.AI evaluation quality, they have been tested using GPT-4o mainly. And the demo that I'm doing is also against GPT-4o. But if you use like smaller models, which have more trouble following instructions, then you may not get very good evaluation results from there. So yeah, everything should work.
Yeah, so if we run locally Olama with Phi 2, and I am not trashing Phi 2, I am a big fan of the Phi model, but Phi 2 is old, again, quoting old, everything is old in the AI world after a couple of weeks. So, but Phi 2 is probably going to work, but of course, is not going to have the quality to evaluate another model because it's kind of small, old, and more. Okay, I get the idea, but again, it's an option, so it's there. It's nice to see what the community are thinking about this. Sorry, Shyam, I completely break your flow. You can go there, and Ravi says thanks. Okay, we have a couple of other questions for later. Please continue.
So the interpretation, the way it shows up is in the report. So if the rating of the interpretation is good, acceptable, and so on, then these metric cards will be colored green. And if it is like not acceptable or bad, then it will start going towards the red shades, right? And similarly for like pass versus fail, if there is even one metric that is considered failed, then the corresponding scenario will be marked as failed. And I think we have one example that shows you what that would look like. So jumping back to the code, sorry, wrong project. So there is the interpretation, and then there is also this concept of diagnostics. So diagnostics is a way for evaluators to report kind of exceptional conditions, right? For example, hey, I'm doing the evaluation, but I had to trim some messages because the input that you provided exceeded the token limit. So then the evaluator will add a diagnostic to the score saying, this is the score I have, but there is also this warning that not the complete conversation was not considered, and so on. And then, of course, the value, which you've already seen. Now, this example showed how to do one evaluator. The next one is going to show how to run multiple. So for that, again, I create all the evaluators that I want. So in this case, I'm creating a coherence and fluency evaluator. And then I add them to this composite evaluator, which itself is also an evaluator, right? So you can add as many of these to the composite evaluator and then say composite evaluator.evaluate. And the interface for doing the evaluation stays exactly the same. So you still pass the messages and the chat configuration, and then you still get back the result. The way you interact with the result is the same. So in this case, there are two results, right? So I say result.get numeric metric with name coherence, and then get another numeric metric with name fluency, and then I check their interpretation and so on. So that part stays exactly the same. And the next thing I wanted to show you is how to write your own evaluator. So as we saw in the report, there is this words evaluator and this measurement system. So I just wanted to show the code for what they look like, right? I keep going to the wrong project, sorry.
Hey, no problem. I like that everything is under the evaluator interface. It's not probably good for me. I'm not a very good coder. You're going to find a lot of crappy names and crappy variables all in the same interface, but it makes sense to have individual evaluators, also the composite one, because the code from there is going to be the same. Hey, I like it. Sorry. I'm just also browsing the code at the same time.
No worries. So this is let's go to word count evaluator first. So this is the word count evaluator, the first score that you saw there. And so the thing about word count evaluator is it's not using AI. So like Peter said, the evaluators can use AI if you need to, but they can also be like simple and they can use like math and other things, right? So in this case, if I look at the evaluate async method for word count, it's just counting the number of words, creating a metric with the name words, and then adding the word count there. There's also a reason that the evaluator gets to provide. So it says like the word count is 39 because the response contains 39 words. It's just putting a string in there. But you can imagine if you're using an LLM to do the evaluation, then you can ask the LLM, why did you produce this score? And then that could be added as a reason in the metric. And then this one adds a default interpretation. I think it's doing something like if it's greater than 100 words, then it's a fail because we asked the LLM to keep the response under 100 words. If it's very small, then also it's kind of not acceptable, but otherwise it's anything about 20 words is good. So it adds such a interpretation to that metric. We can take a quick look at how that is done. So yeah, if it is less than equal to 100 is good. So yeah, it just does a simple thing where it says if it's less than 100 is good, otherwise it's unacceptable. And that's it. And then you return that as the evaluation result. So this is the most kind of simple example of a evaluator. There's not much that you need to do to write one. And the other one is a measurement system evaluator. So what this is doing is because we are asking the LLM for the answer to a astronomy question, like a distance question. So it's kind of the instructions to the LLM in the system prompt we have said only use the imperial system, like your answer should contain the distance in miles, right? So what this is evaluating is, okay, now that the model has produced a response, let's look at it and see which measurement system was used in that response. And so it has a prompt. So this one uses an LLM, unlike the word count. And it has a prompt for an LLM that describes like what measurement systems are. And so different examples of like, what is the measurement system if the answer was like this, right? And then it just asks the LLM to return the response as a single word in the output. And then the evaluation is very simple, right? It takes this prompt, puts the user's model response and message inside that prompt, and then asks the like runs the uses Microsoft.Extensions.AI. So it's saying like chat client.get response for that prompt, right? So it's saying, give me the evaluation response. And the response will be a single word. We have instructed it to do that. And then we try to, we set that value as the value of the metric. In this case, it's a string metric. So whatever value the LLM responded with, we are going to put it in the value. And then the interpretation in this case is going to try to parse that value into an enum. So if the enum parsing succeeded, then if the enum parsing succeeded and the return measurement system was either imperial or US customary, then we consider it good. Otherwise, anything else is not following instructions, and so that is bad. So again, like the flow is very similar. So you create a metric, you add the interpretation, and then you return it as part of a result. So those are the two kind of simple evaluators, custom evaluators that I wanted to show. And we have more examples here for more concepts. So one of them that might be interesting is invoking evaluators that need context, right? So this is the scenario I was mentioning before, where you pass additional context as part of the evaluate async call. So here I have like two evaluators, equivalence and groundedness, and both of them need additional context to do the evaluation. So again, I create a composite evaluator, add both of them there. So the equivalence evaluator needs like a baseline response. So this is saying what a good response looks like, and so that is being passed as one of the contexts. And the other, groundedness, also needs something similar. It's like trying to see if the answer is grounded in whatever context was provided as part of the groundedness evaluator. So again, the way to invoke them remains the same, but at the end we add like both of those contexts, right? And the evaluator will use the equivalence evaluator uses the equivalence context, and the other one uses the grounding context. So that covers most of the interesting kind of concepts at the base evaluation layer that I wanted to cover. I won't go over the other ones. We can move on to the reporting layer now. So in the reporting layer, so I'll show you what a unit test looks like. So this is an example of a unit test that is going to do evaluation and kind of store the value in a report, in a result store, and do the response caching, etc. And so the entry point API that we have for that is called reporting configuration. So the way these tests work is you say, create a reporting configuration and then say, give me a scenario run that is based on that configuration, right? So in this case, I have like, create me a scenario run with this scenario name. And then I'm also adding some tags here because the question is about the moon. I just added a tag that says moon. So I get the scenario run from this configuration, and I'll show you what the configuration means in a bit. But then once you have this scenario run, and notice that I'm saying await using. So the idea is that you have this scenario run. As long as this stays in scope, you can do evaluations. And once this scenario run goes out of scope, the evaluations that you performed are stored into the result store. So the result is, scenario run's result is kind of written to the result store. And again, these examples are doing like astronomy. So I say, how far is moon from the earth, get the response to that question, and then say scenario run.evaluators. And again, like sticking to the theme that we were doing earlier, just like you do multiple evaluations, the API remains exactly the same. So you say scenario run.evaluators. Here are the messages. If you wanted to pass context, you would pass that here too. And then you get back the result, and the way you validate the result is also the same. So I won't go into that again. And I will show you what the reporting configuration looks like. So in this samples, I'm using the same reporting configuration across multiple tests. And what the reporting configuration says is, I want to use a disk-based storage for the results. So it's disk-based reporting configuration .create. And then the storage root path is the folder where you want to store your results and your response caches. I pass in the set of evaluators that I want to use. So every scenario run that is created from this configuration will use these set of evaluators. And in this case, I have just relevance, truth, completeness, measurement system, and word count. So those are the three evaluators that I'm using. I pass in the chat configuration, the same thing that we saw earlier, which contains the iChat client to talk to your LLM. Then there's a flag to say whether or not I want response caching turned on. So in this case, I want to turn it on, but every time I run the test, except for the first time, it will always be fast unless something changed. Then there's an execution name. So this is like the name of your run. And it can be something like the version of your product or the today's date or something like that. And then you can also specify tags at the global level. And once I run that, the report that is produced will look like this, right? So all the scores are logged. There is the coloring for whether something is considered passed or failed. And you can see that the tags that I specify, they show up at the top, right? And in the first row, we are showing all the tags that apply to all the scenarios. So it seems like all the scenarios are using OpenAI, GPT-4o, all of them in this report are storing to disk. And then if I only wanted to see things related to the moon, I can click moon. If I also want to see Neptune, I can click Neptune, and so on, right? So there is like filtering and kind of hierarchical support. Another thing to call out is the name. So the name of the test here was, sorry, example one, sampling and evaluating a single response. And so what we are doing is the fully qualified name of this test is reporting examples dot example one blah blah blah. So like we split the reporting tree is basically split on dots, so you can structure your names and take advantage of the dots and like kind of create a tree for your reports. And
one question there, because I was following the README and the instructions and more to get the report. And basically what I see here, and correct me if I am wrong, is that we need to, first of all, run the test in the command line .NET test, and then do the .NET, can't remember the name, AI eval reports, and then we have all of the parameters.
Yep.
That's how we get this. Yes, sorry, please.
Yep, I can quickly demo that as well. So in this one, we saw like doing a single response, but normally you probably want to sample multiple responses because each LLM response is different. So in this case, we have an example where we are doing a parallel for over like 4 calls to get 4 different responses, and then using the scenario run, a separate scenario run object for each iteration, right? And that is the iteration number is the thing that you see over here. And if I look at this like sampling multiple, you can see that there are 3 iterations under here, and each of them will produce like a score. And we also show the LLM conversation. So each different scenario might have a different kind of response, but we show, you can look at each of those and see what the original LLM response was. And we also show these chat diagnostic details, which say like, was the cache used or did we miss the cache for some reason? And so in this case, we can see there were 3 responses that were sent to the LLMs. And I know that like the first one is going to be the main kind of LLM conversation. The second one is going to be for the relevance, truth, completeness evaluator. And the third one is going to be for the measurement system. Word count doesn't use that, so there is no, it is not hitting the LLM. But you can see all of those were kind of fulfilled from the cache when I ran the report. And as Bruno said, running the report is just simply running .NET AI eval report. I point it to the folder where the cached data and the report results are present. And then I say, this is the name of the file. And we recently added this flag to say, also open that report, right? And so if I just run that again, it will just show me the same report. There are a couple more examples in here that show you, so if you wanted to create your own storage provider and store it in SQLite, how would you do that? There is some examples for that, and you can take a look at those later. But I think given that we have 10 minutes left, I think I've covered most of the concepts. Oh, one other thing that I wanted to show you is how the things are stored on disk. So this is the folder that I specified on the command line, like qtemp AI samples. If I look under there, there is, for the disk-based cache, there is a cache folder. And then for results, there is a results folder. And the SQLite tests also create this cache.db, which stores like a couple of scenarios in there as well.
I was going literally to ask you if we have time, what are we using to do the cache, the cache and more? There it is. Sorry, please.
So if we can look at a few examples of what is in the cache, right? So in this case, the first example, as we saw, there were 3 requests, right? All of them were fulfilled from the cache. There is a cache key, which also shows up in the report. Like, you can show it again. So this is the cache key. And so all of these apply to that particular folder, but in there we have this contents.data. So this is the cached response. So it's going to, if so long as the cache key for all the input messages stays the same, it's going to go here and it's just going to fetch this response and give that back to you. So as you can see, it is just a serialized form of the response. So this one looks like the relevance, truth, and completeness. It produced the relevance score of 5 with that reasoning and so on. So this is actually the evaluation happening, right? So it looks like nothing changed in the input prompt, nothing changed in the evaluator. So it's just using the same evaluation response as before. And all of them are similar, right? There is also this entry.json which says this particular one was for this scenario, this iteration, and it was created at this time. And we have a default expiration policy for the cache. So it will, by default, we expire it in 2 weeks, but you can tweak that in the API as well. And that was the cache side of things. And this is the results. So once you have the evaluation results, they are stored per iteration in a single JSON file in the disk case. So again, you have like scenario iteration, the name of your execution, the creation time, the messages that were evaluated. So this is the original response that was evaluated. And then this is some metadata that OpenAI includes with the messages, right? Like the token counts and everything. And then after that, it has the evaluation results. So each metric that you saw in the report is kind of stored here. So there is the words metric, which is numeric, which has value 39. The reasons and the interpretation, they're all available here. So we have like a default report format, but once you have this data, you can do whatever you want with it. Like you can put it in your telemetry system and App Insights, or do reports using Power BI and so on. So yeah, I think that's mostly covers what I wanted to talk about.
No, that's amazing. I love it. I already thinking how I am going to probably, we have this demo which is eShop Lite, which is basically a super small e-commerce site, and we use different, we have different versions with semantic search using in-memory vector database, another using ChromaDB, another using DeepSeek models, and I already thinking how I can do one using this, or take a look after a couple of users use this a little, if the responses from the models are good or not. Hey, there is something there. Related to that, I know that we share the sample folder, which is in the .NET AI sample repo. If someone wants to raise an issue, propose a PR, more, that's the right way to do, or we want them to go to the extension? Do we have any kind of,
Yeah.
because samples are in the AI samples repo and the code is here. That's correct, yes?
Yes, so all the samples, including MEAI, we want to put this AI samples in one place. So that's why that repo exists. But the extensions repo is where we are managing the project, right? So if we go under issues, we have, so this is a repo that includes multiple things, including Microsoft Extensions AI, Microsoft Extensions AI Evaluation, some ASP.NET components, and so on. So, but there is a label that we have, AI eval. So area AI eval. This will show you all the issues that we have currently. And we also have, like, if you go into any of those issues, there is a project. If you click on that, you can also see our kind of backlog and like what we are working on and stuff.
Yes, I think that's not public, but just in case,
Okay.
I think this is just for us. But yes, the main repo is public, so that's fine. By the way, this is always a nice moment to remind everyone here that this is open source. We are doing a lot of things and sharing with everyone to have this. Okay, but you answer my question, because I didn't know if AI samples was the place. I'm guessing if someone wants to create an amazing Aspire sample using this, go for AI samples and make a pull request there. If you find something that you think it's closer to the extension AI evaluators, go to the other repo. I was just trying to basically figure out the two places, but hey, I like it a lot. I know that we are getting to the end of the hour. We have some comments, and yes, I know I have the same issue that in Twitch, not to Sempra, sorry if I kill your name, saying that yes, when we shared ready-to-go code that have a lot of comments. And no, it's super hard to read if you are not used to that. I'm in the same team, but I feel about this. Yes, I know. So we have this. Jose saying that thanks, this was great. Not to sempre say hey again. There is a lot of people who will join late and more. But hey, I really, really like it. And once again, to have the groundedness and the other metrics available for us right now when we start to do applications, I know that it's not the super usual common for all .NET apps scenario, but we need this, and it's here to be used for everyone. So I don't know, Peter, Shyam, anything else? We're probably going to wrap up. I see people starting to say hi in the comments. Anything else to wrap up the session?
I would definitely say, like, please try it out. We are eager to hear your feedback. Please give us feedback on how you find the library and how different use cases that you find for it. Peter, do you want to share about like the timeline or like the
for the trending
like
stuff,
what Bruno was mentioning, like what's coming and
yeah. So we are working on those safety evaluators, like Shyam mentioned before. So that'll be a big addition to the library. We're also adding some more additions to the reporting. So the reporting is actually advancing very rapidly with filtering. We're going to add searching. We're going to add trending. So you can actually do reporting on, like, say, the last 10 runs in your pipeline. And then all that will be compiled into one report, and you can actually open up a particular scenario and see how did this perform for the last 10 runs and which releases were successful and which ones weren't, or is it trending up, is it trending down, and so forth like that. So, and we're eager for feedback. As Shyam mentioned, we're working with lots of different teams across Microsoft that are adopting this, and also external teams. And we'd love to know what sort of issues you might be running into or how we can improve it. So, yeah.
Hey, when we have the security one and also the couple of ones that you show in the slide number 2 that are coming, that's maybe a good moment to do kind of a refresh, because yes, there is a super amazing space to do this, and it's part to us to start to. Everybody's using large language model right now. There is a lot of people using these Gen AI tools. This is something else that we can help them to. We can give them they can build better applications. So hey. Once again, thanks a lot, Peter, Shyam. There was a story behind this, how we get here. So I will really appreciate that you're both here today. And thanks, everyone. And see you in the next one. Bye-bye.
Thanks.
Thank you, everyone.